This video is for integrated 2. This is on our completing the square worksheet. And you'll notice you're doing the ones on here, which are the odds. Okay, I took off all the evens, so we're only doing the odds, which is what your worksheet was that was assigned in Canvas. And what our goal is to get these problems to look like the following. We want to get them to look like the ones we were doing the other day, where we have something like nx plus 4 squared equals, let's say, 25. And we solve this where we have a perfect square on this side. And we don't need to multiply that out. We can actually square root it, square root the other side, and when we square root the 25, we get a positive and negative 5. Subtract the 4, and then we're going to get two answers. One answer is going to be x is equal to 1. The other answer is going to be x is equal to negative 9. Negative 4 plus 5 and negative 4 minus 5. Those are the two problems that we're working out, and those would be our two answers. That is our goal. Okay, these ones are not in that form, so we're trying to get them to look like that form. Okay, so what I'm going to do is, number one, this 38 here is not making this a perfect square. Okay, so I am going to rewrite this p squared plus 14p. I am going to add the 38 to the other side, and then I need to figure out what I need to add to both sides, because if I add to one side, I have to add to the other side to make it a perfect square. So right now, I'm literally going to be making it into a square. So I want a square such that I have my x squared. Sorry, this is p squared. I have my 14p, which is in my problem, split evenly. So how can I split this to make it a square? I'll have a 7p and a 7p. That way it makes it even on both sides. This will be a p plus 7. This will be a p plus 7. And I have a square because both sides are the same. Now, that's what I have currently, p squared plus 14p on the left-hand side of my equation. Now, the problem is, you'll notice that there's a blank here. Whatever goes there is what's going to go here to make it a perfect square. So what that needed to be is a 7 times 7, which is a 49. So we're going to add 49 here, and we're going to add 49 here. Now, the whole reason we did this was because we wanted to make this left-hand side into a perfect square. So it is going to be a p plus 7 squared. As you can see from over here, p plus 7, p plus 7. Okay. On the other side, when I add that up, I'm going to get an 87. So now it looks like the problem I just was working out at the beginning. So I'm going to square root both sides. I'm going to get a p plus 7 is equal to plus or minus the square root of 87. Now, if you can simplify the square root of 87, you want to. I know 87 is not a perfect square, but is there any square that goes into 87 as a factor? And if I'm thinking about my squares, 4 is a square, 9 is a square, neither one of those goes into it. 16, no. Let's see, 5 squared, 25, no. 6 squared, 36, no. 7 squared, 49, no. And 8 squared, 64, no. And once I get to 9 squared, we get an 81. And after that is 10 squared, which is 100. None of those are perfect squares that are a factor in 87. Okay, so these squares are not in 87. So I'm going to leave that 87 as is. And the last thing I'm going to do is I'm going to minus the 7. And my answer is going to be negative 7 plus or minus the square root of 87. When you get an answer like this is an irrational answer. The root 87 is irrational. Okay. So what that means is this would not have been factorable. So we could not have tried to do this by factoring and using the zero product property. So this is another method. This method works whether it's factorable or not. Okay, on number 3. So again, I'm going to do a box, and I'm just going to make one. Oops. And I am going to I don't want to adjust that. Okay. And I am going to just copy this real quick so I don't have to do this over and over again. So let me just copy this. Okay, so I'm going to copy and paste. I'm going to paste one down here. Okay, so for this problem, again, I have a 51 minus 51. That's not helping me. So I'm going to add the 51 to the other side. And I need to figure out what I'm adding to this side and adding to this side to make it into a perfect square. Now, in this case, we should hopefully know what we're going to be adding because the problem above also had a 14. So this is going to be an a squared. My 14a is going to be split as a 7a and a 7a. So I have a squared plus 14a. So on the outside, this is going to be an a plus 7. This is going to be an a plus 7, making it a square. And then what I'm missing is this 49. So I'm going to add 49 here, and I'm going to add 49 here. So my left-hand side is going to be a plus 7 squared. And on the right-hand side, I am going to end up getting a 100. Now, in this case, we're actually getting a nice answer. This one actually would have been factorable, but on this whole page, both front and back, we are practicing completing the square, whether it's factorable or not. So now I'm going to take the square root, and I get an a plus 7 is equal to positive and negative 10. Then I am going to minus my 7. I'm going to have a negative 7 plus or minus 10. Now, if I'm thinking about negative 7 plus 10, that's going to give me a 3. If I'm thinking about negative 7 minus 10, that is going to give me a negative 17, and that's my answer. Now, in this problem, since we did have a perfect square on the other side, and we ended up getting a nice number, again, this one would have been factorable, but we are doing completing the square on this whole page. Okay, so the next one, x squared plus 6x, I'm going to minus 8. So I am going to have an x squared. I'm going to split my 6x evenly into a 3x and a 3x. So that's going to give me an x plus 3 and an x plus 3. And then I need to figure out what was I missing. Well, this should have been a 9, x squared plus 6x plus 9. So I'm going to add 9 here. And if I add it to one side, I have to add it to the other side. Now, the x squared plus 6x plus 9 is the same as the outside of that box, which is an x plus 3 squared. They are equivalent. And then on the right-hand side, I get a 1. So now I'm going to get x plus 3 is equal to, and when I take the square root of the 1, I get a positive and negative 1. So I am going to have negative 3 plus and minus 1. Well, negative 3 plus 1 is a negative 2. Negative 3 minus 1 is a negative 4. And those were our two answers. And again, this one would have been factorable. We got nice answers, but we're practicing completing the square. Okay, so this is going to be an x squared plus 4x equal 15. Now, again, we have actually seen this 14 a couple of times. It's going to be split as a 7 and a 7. That's going to give me an x plus 7 and an x plus 7, which means I should have had a 49 to make it a perfect square. So I'm going to add 49. I'm going to add 49. So I am going to have x plus 7 squared is equal to, and I'm going to end up getting a 64 here. So I'm going to get an x plus 1 is equal to positive and negative 8 when I square root. So x is equal to a -7 plus or minus 8. Again, getting nice answers. It was a 64 on the other side, which is a perfect square. It's rational answers. Could have been factored, practicing completing the square. X is equal to -7 plus 8 is going to be a +1. -7 minus 8 is going to be a -15. On the next one, number 9, okay, let me just get a couple of these here. On number 9, I have r squared minus 4r. I have a 7 on the other side. I'm also going to add the 91 on. Okay, so I'm going to have r squared minus 4r is equal to 98. I'm going to need to figure out what I'm going to put there. So I have an r squared. My -4r is going to be split evenly as a -2r and a -2r. I'm really just taking half of the -4. So I'm going to get an r minus 2 and I'm going to get an r minus 2. Now, to make it a perfect square, -2 and -2 gave me a 4 here. So this should have been a +4 and this should have been a +4. So this is going to be an r minus 2 squared, because that's equivalent, is equal to a 102. So now I'm going to take the square root of both sides. I'm going to have r minus 2 is equal to a plus or minus the square root of 102. Now, when I'm doing this, I do want to ask myself if I can simplify 102, okay? So if I am looking at the square root of 102, I know for sure that that's a √2 times a √51. Now, a 51 is going to be a √3 and a √7. I can't break any of those down more, so I cannot simplify my 102. So my answer is going to remain with the square root of 102 in it. So this is going to be r is equal to 2 plus or minus the square root of 102. So now in this case, this is a situation where this one would not have been factorable because the square root of 102 is not nice. I would not have gotten rational answers, which is what happens when it's factorable. So I would have had to use the completing the square at this point to solve it. Okay, so this next one, again, we just saw the 4, okay? I have a -5. I'm going to minus the 1. So I'm going to get a k squared minus 4k is equal to a -6, okay? So I have a k squared. We know we're going to split it as a -2 and a -2, just like we did above. So this is going to be a k minus 2 and a k minus 2, giving me a 4. So I'm going to add 4 here and I'm going to add 4 here. Now, I'm going to get a k minus 2 squared is equal to a -2. Now, in the past, if I had to take the square root of a negative, because that's what's going to happen here, I'm going to have a -2 is equal to a positive negative square root of a -2. We would have said no solution, but we have learned that we have something called an imaginary number where I is equal to represents the square root of a -1. So what that means is when I have the square root of a -2, I can think of that as the square root of 2 times the square root of a -1. Okay, and the square root of 2 is √2. I can't simplify that. And the square root of a -1 is an I. I'm going to stick that I in front. And that is what it would simplify to. So over here, I'm going to have k is equal to, well, here, let me do it in 2 steps. K minus 2 is equal to plus or minus I, and then the square root of 2. If you have a negative underneath the square root, you're going to have an I coming out. And then you look at what's left, which is the √2, and I cannot simplify that any further. So I'm going to have k is equal to 2 plus or minus I √2. Again, something like this would not have been factorable. Okay, on number 13. Let me Okay, so let me just get this one more time. Oh, didn't give me all of it. Okay, well, I'll make a new one. Okay, so for this, and eventually our goal is to be able to do this without having to make a box every single time. Okay, but pretend that that actually looked like a square. I'm just going to grab a few here so I've got them. Okay. So for this, on number 13, I have a v squared minus 6v. They already have my negative 91 on the other side. So I'm going to have a v squared. I'm going to split a negative 6v, which I think we saw earlier, negative 3v, negative 3v. So this is going to be a v minus 3. This is going to be a v minus 3. And what is going to complete it is a 9. So I'm going to add 9. I'm going to add 9. So this is going to be a v minus 3 squared is equal to a negative 82. Negative, so I'm going to get an imaginary answer. 82 is not a perfect square. And 82, if I was to break up an 82, let me just do that over here. An 82 would equal the square root. 2 for sure goes into it, and then 41. And I'm not going to break, there's no squares in either of those. So I'm going to be done with the 82. It's going to stay a square root. So I'm going to get a v minus 3 is equal to plus or minus I, because it's a negative that I'm square rooting, square root of 82, which I cannot clean up. And then I get 3 plus or minus I root 82. And that's our answer. Now on number 15, what's going to happen on 15 is we have a number in front of our k. And I don't have my k's on the same side. So first off, let's get the k's on the same side. So I'm going to have 5k squared plus 20k, and I'm going to keep the 60 on the other side. When you have a number in front, you need to factor that number out of everything. So I'm going to have a k squared plus a 4k is equal to 12. So now I am going to work this out. So I'm going to have a k squared. My 4k is split as a 2k and a 2k. So this is going to be a k plus 2. This is a k plus 2. And then what was missing was the 4. So this should have been a plus 4. This should have been a plus 4. So I end up getting a k plus 2 squared is equal to 16. This is going to be nice answers. So I'm going to get k plus 2 is equal to plus or minus 4 when I take the square root. So I'm going to have a negative 2 plus or minus 4. So negative 2 plus 4 is 2. Negative 2 minus 4 is a negative 6. So on this question number 17, you notice we have an 8. Don't like that 8, so I'm going to divide everything by 8. And when I do divide by 8, and I like the 42 being on the other side, and I do need the 16x on the same side as the x squared. So I am going to end up getting x squared plus 2x. And I'm going to work this out twice here, showing you could do it as a fraction or you can do it as a decimal. Let me just move this over more, give myself a little more space. Okay, so that would have been x squared plus 2x, give myself some space, equals 42 over 8. I could reduce to a 21 over 4. Now, I could also have had it as a decimal, and as a decimal, that would have been a 5.25 when I do that math. Okay. Just going to move this. Okay. So I am going to have an x squared, and my 2x is going to be split as an x and an x. So I'm going to have an x plus 1, and I'm going to have an x plus 1. Now, what I need to add to both sides is 1. So here, I'm going to add a 1. Now, it is a 1, but I'm going to think of the 1 on the other side as a 4 over 4. That's really the same as 1. Okay, I'm just writing it so that I can do the math easier. So this side here is going to be an x plus 1 squared is equal to 25 over 4. I'm going to square root both sides. I get, when I square root of 25 over 4, I get a positive and negative. Square root the top, which is 5, square root the bottom, which is 2. Now, I can really think about this 1. I can rewrite that 1 as a 2 over 2. That's really the same. And if you're wondering why I did that, it's because the other side has a half. So I'm just writing the 1 in a way that's going to be easier math for me. So I am going to have an x equal, and I'm going to write this like this, a negative 2 minus 5, plus or minus, because this is going to be a positive and a negative. I forgot my positive. I'm going to subtract the 2 halves, but since both sides are halves, I can do it this way and put the whole thing over 2. So I'm really subtracting a negative 2 plus or minus 5 over 2. And when I do that math, a negative 2 plus 2 is a 3. So that will be a 3 over 2 is going to be one answer. And a negative 2 minus 5 is a negative 7. So one answer is going to be a negative 7 over 2. So you could do it like that. Now, if you prefer to do it as a decimal, I have it, the 21 over 4 as a decimal on the other side. I still am going to add 1 to both sides. Okay. This side's going to be an x plus 1 squared is equal to a 6.25. Now, a 6.25 actually is nice because 25 squared, which is one of those ones I said, hey, let's know 25 squared, that's really 625. So when I see a 6.25, I know that's going to be a 2.5 squared. That's really what gave me a 6.25. So I'm going to square root this side, get an x plus 1. I'm going to square root the other side and get a plus or minus 2.5. So I'm going to have a negative 1 plus or minus 2.5. Negative 1 plus 2.5 is a 1.5, which is the same as my 3 halves. Negative 1 minus 2.5 is a negative 3.5, which is the same as my negative 7 halves. So you see I get the same answer. So you can do it as a fraction. You can do it as a decimal. Both will result giving you the same answer. Okay, on 19, let me just move this. Okay, so on 19, I am first going to subtract the 8a, bring it over to this side. I need to divide everything by 2, everything by 2, everything by 2. I get a squared minus 4a equals a negative 3. So I have my a squared, my negative 4a split as a negative 2a and a negative 2a. And again, after you do this enough, hopefully you will know what you need to complete that square. That's our goal, not to have to use the box. So what did I really do? I took half of this, which is negative 2. Then what's going to happen is I'm going to take my negative 2 times my negative 2, which really is a negative 2 squared. So that's a 4. So again, I took half of this, which is negative 2, and then I squared it, which gave me 4. That's really what's happening. Okay. Sorry, trying to erase, not scribble more. So that's going to be a plus 4. That's going to be a plus 4. I end up with an a minus 2 squared is equal to a 1. Square root both sides. A minus 2 equals plus or minus 1. I'm going to add the 2, and I'm going to get 2 answers. A is 3. That's one answer. The other answer is A is 1. Now, again, would have been factorable, but we're practicing completing the square. Okay, 21. Okay, I'm going to have it be a 4n squared plus 4n. I'm going to take the 36 to the other side. I'm going to divide by 4. I'm going to divide by 4, divide by 4. I get n squared plus n is equal to a negative 9. Okay, so in this case, this one is not going to be as nice because my n is not an even number. Okay, so I'm actually going to work this out two ways. I'm going to do it as with fractions. I'm going to do it with decimals. So here, let me give myself some more space. I'm going to move this one for a second. Okay. Sorry. So I am going to okay, so I'm going to again do this two ways. So I have the n squared plus n equals negative 9. I'm going to rewrite that here on the other side also. N squared plus n equals negative 9. One side I'm going to do decimals, one side I'm going to do fractions, okay? So n squared, n squared. My n is really 1/2 n, 1/2 n. So this would be an n plus 1/2. This would be an n plus 1/2, which would give me a 1/4. So I could add 1/4. I could add 1/4. Now, on this side, this would be an n plus 1/2 squared. And in place of the negative 9, I can write it as a fourth. That would be a negative 36 fourths. It's the same as a negative 9. I am going to be adding my 1/4. So I'm going to get an n plus 1/2 squared is equal to a negative 35 fourths. So I'm going to get an n plus 1/2 is equal to a positive and negative I, because it is a negative. And when I take the square root of 35, I get the square root of 35. Let me move this slightly. I end up getting the square root of a negative 35 is plus or minus I root 35, and the square root of 4 is 2. Now you'll notice I have a 1/2 and I have a I root 35 over 2. So I can simplify this to a negative n equals a negative 1, because I'm subtracting the 1/2, but I'm also doing it to another half. So since both of these are over 2, that is my answer. Now, if the fractions are a little too confusing, you can also do it using decimals. So it was an n squared. Half of an n is a 0.5 n. Let me just put a 0.5 and not the 0. Give myself more space. Okay, 0.5 n, 0.5 n. So this is going to be an n plus 0.5. This is going to be an n plus 0.5. 0.5 times 0.5 is a 0.25. So I'm going to add a 0.25 here. I'm going to add a 0.25 here. Now this is going to be an n plus 0.5 squared. And I'm going to get a negative 8.75. And then I'm going to get an n plus 0.5 is equal to plus or minus I root 8.75. And that is not going to be a pretty square root to be taking. Okay. So I'm just going to leave it like that. Temporarily. I'm going to clean it up here in a second. So I have a negative 5.5 plus or minus I and the square root of 8.75. Now, when I see that it's like a 0.75, I do realize that I probably could simplify it. I probably have a 0.25 in here because as you think about money, 875. Okay, I do have quarters in 875. So how many quarters in 875? If I was to take out that 0.5, if I was to think about this as an 8.75, it is a 0.25 times, and when I do that in my calculator, it is a 35. Okay, it is a 35. It would have been 35 quarters. So I could simplify this to n equal a negative 0.5 plus or minus 0.5, because that's going to be the square root of this. Oh, with an I, because it has an I, root 35. That is the same answer as what I have. Down the road, we definitely want to start doing it in the fraction form. Okay, it's a little cleaner. On 23. Okay, so on 23, let me do it in blue since I've got writing all over this. I am going to have a 10p squared plus a 5p. I am going to subtract 77 to the other side, and I'm going to get a negative 68. I don't want that 10 there, so I'm going to divide by 10, divide by 10, divide by 10. I get a p squared plus, here that can end up being a 2 over 5p, and a negative 68 over 10 is going to be divisible by 2, so that's going to be a negative 34 over 5. Okay. Now, if I'm going to do this as a fraction, I'm going to have a p squared, and it's a 1/5 p and a 1/5 p. So this is going to be a p plus 1/5, a p plus 1/5, which is going to give me a 1 over 25. So I'm going to be putting in here, let me space this out a little bit. I'm going to be putting in here a 1 over 25 and a 1 over 25. Now, this is going to be a p plus 1/5 squared. On the other side, I can rewrite this, multiplying top and bottom by 5. Okay, so 34 times 5, I get a negative 170 over 5, over 25. Sorry, I'm trying to get it to be a 25. So I multiply top and bottom by 5. I can also put this in the graphing calculator and it will do the math for you, or Desmos. So I'm going to end up with a p plus 1 over 5 squared is equal to a negative 169 over 25. Take the square root of this side, I get a p plus 1/5. I take the square root of the other side, I'm going to get a positive and negative 13/5 I. And then I'm going to minus the 1/5 from both sides, but since they're both fifths, I'm going to put it all over 5. So the cleaned up version is going to be a negative 1 plus or minus 13I. And that's our answer. Okay, I'm just going to do this one as a fraction. Hopefully this helps you out. Good luck on the assignment.